Light, shadows, and reflections. Lesson preview. Light energy. Sources of light. Luminous and non-luminous objects. Transparent, opaque, and translucent objects. How light travels. Light always travels in a straight line. Rays and beams. Shadows. Pinhole camera. Eclipses. Reflection of light. Can you imagine a world without light? We can see objects around us only in presence of light. We need light in our daily life to perform most of our activities like reading, playing, cooking, eating, bathing, driving, studying, etc. Light is a form of energy that gives us the sensation of sight. Light itself is not visible. Look carefully at a beam of sunlight coming into your room through chinks in the curtains. You will notice that it is actually the dust particles that shine when light falls on them. These dust particles thus light up the path of the beam of light. It seems as if you are actually seeing light, whereas what you are seeing are shining dust particles. If there were absolutely no dust particles in the room, the path of light would not be visible. Light energy. Green plants prepare food for the entire living world by the process of photosynthesis using the energy of sunlight. Light is hence a form of energy, essential for all life on Earth. During photosynthesis, oxygen is given out by plants. Humans and animals breathe in oxygen to survive. When wood is burnt for cooking or heating, we are actually using the energy of sunlight locked up in plants. In the same way, all fossil fuels, coal, petroleum, natural gas, have the energy derived from the energy of sunlight, which is released when they are burnt for various purposes. Nature converts dead plants and animals into fossil fuels over millions of years. Thus, we depend on light energy to fulfill our requirements of food, oxygen, and fuel. Sources of light. Stars, electric bulb, and lighted candle can produce light. These are sources of light. Stars are natural sources of light. Electric bulb and candle are human-made sources of light. Luminous and non-luminous objects. Objects like the sun, tube light, bulb and torch which emit their own light are called luminous objects. Objects which do not emit their own light like chair, table, pen, moon, earth, etc. are called non-luminous objects. We are able to see these objects when light from a luminous body falls on them and then travels towards our eyes. Most of the objects are non-luminous. Earth and all other planets and natural satellites are also non-luminous objects. They seem to be shining because of the light of the sun that is reflected off them to reach our eyes. Transparent, opaque, and translucent objects. Non-luminous objects are of three types: transparent, opaque, and translucent objects. Transparent objects are those objects which allow light to pass through them and we are able to see through them. Some examples are glass, water and air. Opaque objects are those objects which do not allow light to pass through them. Some examples are wood, door, brick, etc. Translucent objects are those objects through which we can see but not very clearly. These objects allow light to partially pass through them. Examples are tissue paper, butter paper, cellophane, and plastic. Transparent objects. Opaque objects. Translucent objects. Activity. Take 10 items like a cardboard, notebook, cellophane sheet, plastic scale, eraser, hanky, a glass, tracing paper, and pencil case. Place them in front of your eyes one by one, and look through them at a faraway object with light behind you. What do you observe? Is there any difference between the various objects? Note down your observation. What do you infer? How light travels. Light travels in a vacuum at the speed of about 3 lakh km per second in air. No known object can travel as fast as light. The distance of the Sun from Earth is 149.6 million kilometers. Light takes about 8 minutes to travel from the Sun to Earth. This means you see the Sun rising about 8 minutes after it has actually risen. Some other stars are so far away from the Earth that their light takes millions of years to reach the Earth. Thus, when you look at these stars, you are in fact seeing them as they looked millions of years ago. If a star explodes today, the light of explosion can only be seen on the Earth millions of years later. Light always travels in a straight line. When you shine a torch in the dark, light from it appears to go straight outwards. A cinema projector also sends light in a straight path to the screen. These observations tell us that light travels in a straight line. Activity. Take a rubber tube about 30 cm long. Look at a lighted candle through it. You will see the candle flame as long as you keep the tube straight. Now, bend the tube. Can you see the candle flame? No, because light cannot bend along the tube. This property of light, which makes it travel only in straight lines, is called rectilinear propagation of light. Rays and beams. A very narrow path of light shown by a line with an arrowhead showing the direction in which it is traveling is called a ray of light. A beam of light comprises several rays. The rays can be parallel to one another, or if the source of light is very small, the rays will spread outwards. Shadows. While walking in the sun, you must have seen shadows of plants, trees, houses, and even your own self. You must have wondered what a shadow is and how it is formed. When light falls on an opaque object, rays of light cannot pass through it, and the area behind the object appears dark as this area does not receive any light from the source. This area of darkness behind an object where the light is not able to reach is known as the shadow of object. Activity. Take a few opaque objects in the sunlight and hold them one by one slightly above the ground. You will see dark patches formed by each on the ground. These are shadows. Can you identify the object by simply looking at its shadow? Activity. Stand in an open field in the night along with your friends. See that there is no tree or building behind your friend. Shine a torch on your friend's face. Do you see a shadow of your friend? Now ask another friend to hold a sheet of cardboard or paper behind him. What do you see? You will see your friend's shadow. This shows that you need a screen to form a shadow. Activity. Place a book near a white wall. Direct a beam of light on the book from a distance. Observe the shadow on the wall. Now move the torch closer to the book and observe again. Now move the torch even closer to the book. Observe what happens. The size of the shadow varies depending on the size of the source of light, and the distance between the object and the source of light. The shadow gets smaller as the distance between the object and the source of light increases. No shadow is seen at a stage when the distance between the screen and the object becomes too large. Our shadow changes in length and direction during the day as the sun changes its position in the sky. Morning, noon, evening. Pinhole camera. Activity. Take two cardboard boxes, shoe boxes, one of which can slide inside another with no gap between them. Cut one side of each box. Make a small hole in the center of the bigger box opposite the cut side. 5G. A. In the second box, cut a square about 5 times 6 centimeters, and cover this with a tracing paper. Figure B. Now slide the smaller box into the larger box so that the side with the tracing paper may be inside. 5G. C. The pinhole camera is ready for use. Place a source of light like a torch or a candle in front of the camera and look at the screen. You will see the image of the candle on the screen. However, the image will be inverted. You can try looking at distant objects like a tree or a building through your pinhole camera. It must, however, be made certain that the objects you wish to see are in bright sunlight. You will have to slide the inner box backward or forward till you get a picture on the tracing paper. Remember to cover your head and the camera with a black piece of cloth. Pinhole camera in nature. Do you know that a pinhole camera also exists in nature? Have you seen circular images of sunlight when passing under a tree covered with a large number of leaves? These images are actually the pinhole images of the sun. The gaps between the leaves act as pinholes. A pinhole camera is based on the principle known as rectilinear propagation of light. Eclipses. The sun is a source of light as it has its own light. The earth and the moon are non-luminous opaque objects. Does the earth or the moon also cast shadow when sunlight falls on it? Can we see this shadow? The answer to both these questions is yes. The eclipses of the sun and the moon, which you may have seen, occur because of their shadows. Solar eclipse. When the sun, moon and earth come in a straight line, with the moon in the middle, the shadow of the moon may fall on some parts of the earth. A solar eclipse can be seen from these areas on the earth. In the figure given alongside, the sun will be blocked totally at places in region O on the earth, and a total solar eclipse can be seen from there. In the rest of the region, as the sun will be partially blocked by the moon, so a partial solar eclipse may be seen from there. During a solar eclipse, the dark side of the moon faces the earth. Hence, a solar eclipse always occurs on a new moon day. Lunar eclipse. In a lunar eclipse, the shadow of the earth falls on the moon, when the sun, earth and moon come in a straight line, and the earth is in the middle. When the moon is completely behind the earth, no light from the sun reaches it, and we see a total lunar eclipse. A partial lunar eclipse can be seen when the moon is partially behind the earth. When a lunar eclipse occurs, the moon's bright side faces the earth. Hence, a lunar eclipse always occurs on a full moon day. Reflection of light. When light falls on a polished surface like glass, it bounces back. This phenomenon is referred to as reflection of light. The amount of light reflected from an object depends on the surface of the object, whether it is smooth or rough. Opaque objects reflect maximum light. We can see ourselves in the mirror because of reflection. We can also see reflection of objects like plants, buildings, etc. in water. Reflection of light causes the formation of images. Activity. Ask one of your friends to stand in a corner of a dark room holding a mirror in one hand. You stand on the opposite side of the room with a torch. Switch on the torch and adjust its beam so that it may fall on the mirror which your friend is holding. What do you observe? You will see a patch of light on the other side. Now adjust the direction of the torch so that the patch of light may fall on another person standing in the room as shown in the figure. This shows that a mirror changes the direction of light that falls on it. A mirror reflects the light traveling in a straight line in a different direction. Activity. Take a big thermocol sheet. Fix a comb on one side and a mirror on the opposite side. Spread a dark-colored sheet of black paper between the comb and the mirror. Now, direct a beam of light from a torch through the comb as shown in the figure. You will observe a pattern as shown in the figure. This shows that light rays travel in straight lines when reflected by the mirror.